Number 1, the student council sold flowers for the Sweetheart Dance as a fundraising project. They sold 200 flowers that included carnations, roses, and daisies. The carnations sold for $1.50. The roses sold for $3.75. The daisies sold for $2.25. Most of the order was carnations, and there were 20 fewer roses than daisies. The total flower sales came to 453. So this one, it broke it into 3 parts. First, it says write a system of linear equations that can be used to determine how many of each type of flower were ordered and sold. So that's just writing your equation. So we need to label our variables first. So what do you want your variables to be?
C, R, D.
C, R, D, good. Okay, so carnations are going to be C. R is going to be roses. And D is going to be, oh, I spelled daisies wrong. Daisies. So I sold a total of 200. So C plus R plus D is going to equal 200. And my total amount of money is 453. So carnations sold for 150 C plus roses sold for 375 R plus daisies sold for 225 D. I ran out of space there. Since I have 3 variables, I need 3 equations. There are 20 fewer roses than daisies. So I know I'm comparing roses and daisies. And because there are 20 fewer roses than daisies, I am going to subtract 20 from the daisies to make them equal. Because roses already has 20 fewer. So you have to subtract 20 from the daisies to make them equal. Part B says solve the system of equations in 3 variables. Because this first part is calculator, I would recommend using the calculator. You're not going to have time to do this by hand on the test. So in the calculator, see, I think over here is the best spot. We're going to go menu 3-2 to get the system of linear equations. I have 3 equations. And my variables are C, D, R. And then I'm just going to type them all in. C plus D plus R equals 200. 1.5 C plus 3.75 R plus 2.25 D equals 453. And then the last one, R equals D minus 20. Hit enter, and then this point right here is your answer. 88, 66, 46. Part C says justify the solution to the systems of 3 equations and 3 variables in terms of the problem situation. So that just means what are these numbers, what do they mean, what do they stand for? Well, I have 88 carnations, 66 roses, and 46 daisies. Alright, so those are your 3 parts for that problem. Number 2, your school's Key Club decided to sell fruit baskets to raise money for a local charity. The club sold a total of 80 fruit baskets. There are 3 different types of fruit baskets. Small, sold for $15.75, medium for $25, and large for $32.50. Each Key Club took in a total of, the Key Club took in a total of $2,086.25. They sold twice as many large baskets as small baskets. How many small baskets were sold? So I will say S is the small ones, M is the medium, and L is the large. So I sold a total of 80 baskets. So S plus M plus L is 80. My total amount of money was $2,086.25. So 1575 S plus 25M plus 3250L equals 2,086 and 25 cents. And then I sold twice as many large as small. So I know I'm comparing large and small. And since large is already twice as many, to make it equal, I'm going to multiply small by 2. All right, same thing. Go to your calculator. 3 variables. Oops. Oh, let me do this again. I used S, comma M, comma L. All right, so S plus M plus L equals 80. 15.75 S plus 25 M plus 3250 L equals 2,086.25. And L equals S times 2. All right, and so my answer is 15, 35, and 30, but all I'm concerned about are the small baskets. So small baskets are the first one, S, so small baskets was 15. Number 3, find a point that lies in the solution set to the graph system of linear inequalities. Any point in the dark shaded region is going to be a solution. So you can pick any point. 0, 0 would be one example. But any point in the dark shaded region. If it's on the solid line, it's a solution. If it's on the dotted line, it is not a solution. All right, number 4. My graph isn't great for number 4, but just do your best on it. Dry cleaner charges $4 for a clean pair of pants, $3 for a clean shirt. You want to get at least 8 items cleaned, and you have $33 to spend on dry cleaning. Write a system of inequalities. So because it says inequalities and it has this word at least, you know it's going to be a greater than or a less than sign. I'm going to make pants X. I'm going to make shirts Y. So 4X plus 3Y, and the money that I have to spend is 33. And I cannot go any bigger than 33 because that is all the money I have to spend. So my alligator is going to eat 33. And I need at least 8 items. So X plus Y can be greater than or equal to 8 because I need at least 8. Now, in order to graph these, you have to get Y by itself. So over here, I'm going to minus X. Y is greater than or equal to negative X plus 8. So 1, 2, 4, 6, 7, 8. All right. And greater than. And then this guy, 4X plus 3Y is less than or equal to 33. Minus 4X. 3Y is less than or equal to negative 4X plus 33. Divide by 3. So Y is less than or equal to negative 4/3 X plus 11. So I'm going to start up here at 11. And I'm going to go down 4 over 3. So I know it kind of looks weird, but your graph does kind of something like that. And that one is shading less than. Alright, so Y is greater than there, so less than there. And so here is where I match up. Okay. Number 5. This is your non-calculator section, so we need to be doing this without a calculator. Same thing as the front. We need to switch both of these guys to be y equals. So 4x plus 3y is greater than negative 6. Move your x over. Divide by 3. Over here. Move your x over. Divide by negative 3. Since you're dividing by a negative number, you need to, bless you, flip your inequality sign. So positive 1/3 x plus 3. Alright, so now I'm going to graph both of these. So this one I'm going to start at 3, up 1 over 3. And it's greater than, so I'm shading above. This one I'm going to start at 2, down 4, over 3. And that one is a dotted line. And also shading above. So this area right here is where they match up. Alrighty, moving on. Substitution and elimination. Since I'm telling you to use substitution, you have to use substitution. So I'm going to solve for this y variable right here. So y equals negative 2x minus 3. So I'm going to take what y equals, and I'm going to sub it in the other equation. 2x minus 2 minus 2x minus 3. Did I mess up somewhere? Did I?
I'm not sure. No, you're just going too fast. No, I'm not sure. No, that's not bad. I'm not sure because you oh, that's right, because we switched outside. Never mind.
Okay, I'm good.
Yes.
Okay.
I see what you mean.
Alright, so distribute the negative 2. 2x plus 4x plus 6 equals negative 12. Combine like terms. 6x plus 6 equals negative 12. Solve for x.
So every time you have a substitution, we have a y by itself that you need to solve for?
Yep, that's what I would do. So I get x equals negative 3. And then I'm going to take negative 3. I'm going to plug it in here for x. So y equals negative 2 times negative 3 minus 3. So y equals 6 minus 3. Y equals 3. And so final answer as a coordinate point, negative 3, 3. So you have to use substitution if I ask for substitution.
Freaking Jefferson.
Alright, for elimination, I'm going to eliminate a variable. So I'm going to multiply the whole second equation by 2 so that my x's eliminate. Because I want... Wait, here? Double negative, so you add them. Any other questions about the substitution one? Okay, we good? Alright. So I'm going to eliminate x, so I'm going to multiply that by 2. If you eliminated the y's, that's okay. You don't have to do it this way. This is just the way that I saw. So negative 4x plus 4y equals 12. X is eliminate. 3y plus 4y is 7y. Negative 5 plus 12 is 7. And then divide by 7. So y is 1. And then once you get your y, plug it back in, and you can plug it into either one. I'll just do the top one. So 4x plus 3 times 1 equals negative 5. 4x plus 3 equals negative 5. Minus 3. 4x equals negative 8. divide by 4, divide by 4. X is negative 2. So coordinate point, negative 2, 1. Alright, almost done. Trying to just make sure I have time for the last one. 8 and 9, all you have to do is write the equations. So you don't have to solve it or anything because it just wants you to write a system to represent the situation. So you don't have to solve those, which is why it's on the non-calculator side. So all I need is a system. So April is going to the bakery to purchase donuts and cinnamon rolls for office personnel. So I have D, which is going to be the donuts, and R, which is going to be cinnamon rolls. All right, she must purchase at least 30 items. So the items D plus R has to be at least 30, which means can she go over 30? Yes. So we are going to have our alligator mouth eat D plus R because she can go over 30. Okay? She has collected only $30, so we only have $30 to spend. And donuts are 75 cents each. Rolls are $1.25 each. And since I only have $30, we're never going to get bigger than $30. Your alligator is going to eat $30. She can't ever get bigger than $30. And that's all you had to do on this one. On number 9. The Spanish Club is selling food as a fundraiser. A plate of tacos, we're going to say is X. Enchiladas, Y. Tamales, Z. So the X, Y, and Z are going to be the cost of tacos, the cost of enchiladas, the cost of tamales. And it gives me all 3 different situations. So 2 tacos plus 2 enchiladas plus 1 tamale is going to cost $8.50. 3 tacos plus 2 enchiladas plus 2 tamales is going to cost $13. And 1 taco plus 3 enchiladas plus 2 tamales is going to cost $11.25. And once again, I just had to write a system. I didn't have to do anything else. All right, last one, 3 variable. So I'm going to use elimination, and I think I'm going to eliminate the x's. All right, so I can take those 2 guys. X plus 2y plus 3z equals 5. Negative x plus y plus z equals negative 1. X's eliminate. So 3y plus 4z equals 4. So there's one of my equations that I'm going to use later. And then I'm going to take those 2 guys, and I'm going to multiply this whole bottom equation by 3, so my x's eliminate again. Remember, you have to get both the same variable to eliminate. So 3x minus 2y minus z equals 5. And then down here, negative 3x plus 3y plus 3z equals negative 3. So x's go away, and I get y plus, what, just regular y?
2y. You said 3y. 2y.
Sorry, I just meant y then. So negative 2y plus 3y is y. Negative z plus 3z is 2z. You might have, did you do these 2 equations? Did you do the first and the third?
It's negative 3 times 2.
Where are you seeing? I'm doing 3 times this bottom one. Yeah, you might not have done it the same way I did. Yeah, okay, so then you'd be different. You still should end up with the same answer though. All right, so now I'm going to put those two guys together. 3y plus 4z equals 4, and then y plus 2z equals 2. And I'm going to multiply this whole bottom one by negative 2 to get rid of z. Some of you might have gotten rid of y.
By negative 3?
I'm getting rid of z.
Wait, why don't you get rid of the y?
I don't know, I just chose z. It doesn't matter. Do you want me to do the y? Yeah, I can do the y. Okay, so multiply by negative 3. Alright, so 3y plus 4z equals 4. Negative 3y. Y's cancel. Negative 2z equals negative 2. Divide by negative 2, divide by negative 2. So z equals 1. Alright, so now I'm going to take z, I'm going to plug it back in. I'm going to plug it into this one. Y plus 2 times 1 equals 2. Y plus 2 equals 2. So then y equals 0. And then take y and z, plug it back in. I'm going to plug it into the second one. X plus 2, 0 for y, plus 3, 1 for z, equals 5. X plus 0 plus 3 equals 5. Minus 3. X equals 2. And so as a coordinate point, 2, 0, 1.